In this tutorial, I'm going to use completed in the square to solve 2x squared plus 4x minus 6. Obviously, the number in front of the x squared is not a 1, it's a 2 in this case. Now when I graph this, I'll graph a green line this time, I still solve where it crosses the x-axis, or where those two dots are. But before I complete the square, I have to get rid of that 2 in front of that x squared. I have to make that a 1. I multiply both sides of the equation by 1/2. I'm going to put parentheses around the left-hand side of the equation. Anything times 0 is 0, so I already know the right-hand side is equal to 0. So I can rewrite this as 2x squared divided by 2 plus 4x divided by 2 minus 6. And those 2's cancel out. Leaves me with x squared plus 4x divided by 2 is 2x minus 6 divided by 2 is 3, negative 3 or minus 3. And this all equals 0. Notice if I graph this equation, it'll be a gray line. If I graph this equation, its solutions are the same as the green. That means they cross at the x-axis at the same spot. So I've just transformed the first equation into the second equation. And now I'm going to solve for x squared plus 2x minus 3. You could probably factor that, but let's use the completing the square instead. The first thing I'm going to do is put 3 on the other side of the equation. And I accomplish that by adding 3 to both sides of the equation. And this gives me x squared plus 2x is equal to 3. Now I take 1/2 times that 2. Should be 1/2 times 2. This is equal to 1. And I square this 1, or 1 squared. And that, of course, is 1. Now I add 1 to both sides of the equation. I end up with x squared plus 2x plus 1 is equal to 4. And I can factor that as x plus 1 times x plus 1 is equal to 4. Or x plus 1 squared is equal to 4. I'll take the square root of both sides of this equation. So now I have x plus 1 is equal to plus or minus 2. Remember that positive 2 squared is 4 and negative 2 squared is also 4. So I'll write x plus 1 is equal to positive 2 and x plus 1 is equal to negative 2. I want to isolate that x, so I subtract 1 from both sides of the equation, which gives me x is equal to 1. 2 plus negative 1 is 1. So now in the other equation, I'm going to subtract 1 from both sides of that equation as well. And that gives me x is equal to negative 3. Negative 2 minus negative 1 is negative 3. And these are the solution to both equations we're talking about. So if I draw the graph for the second equation, that's what I just solved, which is x squared plus 2x minus 3 is equal to 0. And I draw in 2x squared plus 4x minus 6 is equal to 0. Lo and behold, they both cross the x-axis at the same spots, when x is equal to negative 3 and when x is equal to 1. The key here is when you have 2, you got to get rid of that 2 or something in front of that x squared, you got to get rid of it. So I divided the left and right sides of the equation by 2. And I transform that into another equation, which is x squared plus 2x minus 3 is equal to 0. And both these equations, it turns out, have the same solution, or cross the x-axis at the same spots. And we completed the square for the second equation. Voila, there you go. Next video, I'm going to discuss the proof, or I'm going to show you the proof of the quadratic equation, and it's based upon completing the square, and hopefully you'll hang in there and do all the videos and you'll master the idea of completing the square.